as you guys are looking at the graph, okay, the graph is going to look something like this. Right, so it has these given values. Okay, and I'm going to use these kind of values to point. Now, the first question we asked, remember, was domain. And basically, guys, as we can see in this graph, right there, it looks like the graph is continually going to the left and going to the right, right? Right? However, if you guys notice, if I don't want to zoom out, but if I keep on zooming out, what you guys will notice is the graph is going to continue doing the same thing. It's going to keep on expanding. So therefore, the domain, the set of all x values, is going to keep on getting wider, wider. Like every single x value is going to be contained. So the domain is from -infinity to infinity. Remember, the range was basically saying the y value. So that's going to be basically how low is the graph going to how high, which in this case is, again, -infinity to infinity. The symmetry, remember we looked at symmetry as far as x-axis, y-axis, and origin. So you just want to see, is there any kind of symmetry if I was going to like flip it across the y-axis or the x-axis or both? Would I have any symmetry? Would I get the same graph back? No. So there is no symmetry in this graph. The next thing is we want to look at increasing, decreasing intervals. Now again, when we're doing this, we got to split up the graph. Let's just think about the graph from this little minimum point. You guys agree with me? This is a little minimum. -0.2 to what? -0.1?
Yes.
OK. So just pretend you're walking. Just pretend you're like walking from left to right, right? As you're walking from left to right, from the interval of -infinity all the way to the x value of -0.2, is the graph going up or is the graph going down? Down. So you could say the graph is decreasing from -infinity to -0.2. It's also decreasing from this point, which is at 1, 2. Also, from the x value of 1, which is way up there, as you go to the right, the graph, you're also going down, right? So you could also say from the value of 1, 2. And the graph is increasing. I'm going to write it up here. The graph is increasing from the x value of -0.2 to 1. The next thing is talking about the max and min points, which actually I probably should switch those around next time. So remember, guys, the max and the mins were kind of like your low and high points. But remember, there's different types of max and mins. If it is the absolute lowest or highest point, then we call that an absolute max or an absolute min. If it's just a random low or high point, then we call those relative or local. So here is my min. But you guys can see the graph goes further down, right? So it's not absolute. This is a relative min or local. It doesn't really matter. Relative min, which is at -0.2, -0.1. And then over here, you can see the graph is continually going up. So even though this is a maximum, it is a relative maximum. Relative max. And that point is at 1, 2. For number 6, we're looking for the end behavior. So again, we're basically saying, as this graph goes to the left, what is it doing? Going up or down? Up. Or we say rising. As we follow this graph to the right, what is the graph doing? Going down. Or we say the graph is falling. So you could say rise left, falls right. OK? I don't really like the up, up, or down, down. No, up, down, fall, down. I don't really like that. I like tell me what direction and what it's doing. The next one is it's bounded, above, below, or not bounded at all. So again, guys, think of bounded, like boundaries, right? You can't go beyond this line or whatever else. Well, bounded is basically looking at the height. Is it bounded for any reason? And you guys can see it's going down to infinity and going up to infinity. So there's no boundaries on this graph vertically. So it's not bounded. There's no bounded horizontally, but that's not really what bounded. Bounded is about the height. Is the height bounded at all? Is the graph even, odd, or neither? Since there is no symmetry, it is neither. Remember, even was symmetrical about the y-axis. Odd was symmetrical about the origin. So that's neither. Number 9 was the x-intercept. So we're just finding the values where the graph crosses the x-intercepts. So you could use set notation if you wanted to. So you could say x equals this value, which was -0.4. x equals 0, and x equals 1.3. I'm not using any rounding. I'm just writing them in there. 1.3. OK. And the y-intercepts is where the graph crosses the y-axis, which is at 0. Anybody have any questions on that graph? No? The next one I'll just do really rather quickly.